Hello Legacy Sabers, Marsh here. So this is the first video for the semester 1 review packet. I'm going to go through every single question, so in case you have questions you can kind of watch them. First questions are, determine if the following is a function. So remember guys, to determine if a graph is a function, there's such a thing called the vertical line test. The vertical line test allows us to call, that one, there we go. If I can draw a vertical line, so like that, not very good vertical line, but nevertheless, it only crosses through the graph once, that tells me that I have a function. If it crosses more than once, then you do not have a function. So this would be, yes, it is a function, period, passes vertical line test. Okay. Whoop. A little wonky there on my T. Looking at number 2, however, notice if I draw a vertical line right here, we're going to cross over twice. Big no-no. So this is not a function. So you don't want to use this one. This one's not a function. Okay. Doesn't pass the vertical line test would be the reason for that. Let's scroll down here to the next set. Okay. Now I gotta do some operations. So g of 5, remember that means take 5, plug it into the formula. So I'm going to take 5 and plug it in to g. So I'm going to do my exponents first. So that would be 25. So 3 times 25 plus 5, that would be 75 plus 5, 80, right? So that g of 5 would be 80. Let's try f of x times g of x. So I'm going to multiply 2x minus 1 times 3x squared plus 5. Okay, so now I just got to FOIL, multiply everybody in the front by everybody in the back. So 2x times 3x squared, that would be 6x cubed. 2x times 5, that is 10x. Negative 1 times 3x squared, that's negative 3x squared. And then negative 1 times 5 is negative 5. And then I'll just rewrite them so they're in order, easier to see. And then I'm done with that question. Okay. Number 5 is g of f of x. So that what that means is I'm going to take f, it's composition, remember, so I'm going to take this f, plug it into g. So it's g of 2x minus 1. Oop, I lost the x. So that tells me I'm going to take g, start writing it out. But I'm going to plug f, 2x minus 1, in for the x. So I got to FOIL 2x minus 1 first. I believe that's 4x squared minus 4x plus 1. Just did a quick multiplication. I multiplied 2x minus 1 by 2x minus 1. That's how I got that. Distribute the 3 in. Doesn't want to write the 1 right there. There we go. Plus 3, then plus 5. Alright, let's add that together. So 12x squared minus 12x plus 8 would be my official answer for number 5. Okay, I'm going to do a little line here. 6, f of x plus g of x. So I'm going to take 2x minus 1 and add 3x squared plus 5. So I'm just going to combine some like terms. Pretty easy. 3x squared's alone. Nobody has 2x's. Nobody else has x. So just be plus 4 there. And the final one, this guy. This is an inverse. Now remember how to find an inverse is you take the x and y and swap it around. So I'm going to take the x and y, swap it around, then I'm going to solve for y. So x equals 2y minus 1. Okay. Now I'm going to solve for y. So I'm going to add 1, x plus 1 equals 2y. Divide by 2. Like that. Now I'm going to finish my right. F of negative 1 of x is equal to x plus 1 over 2. Okay. Take a look at number 8, even, odd, or neither. So remember, even means that it folds along the y-axis perfectly and lines up. Odd means the first quadrant will line up with the third quadrant. Or another way to look at it is if I fold over the y-axis and then I fold over the x-axis, it will match. Which if I look at this, notice this hum, if I fold it over the y-axis, it's going to be right here, right? And if I fold it over the x-axis, it's going to line up perfectly with that one. So this is an odd function. Okay. Y for that is symmetric about origin. I would also accept, well, I can fold it over the x and the y-axis and it's good. Okay, let's check a look at this one. Another, what you would have to do if you get algebraic odd and even, you gotta plug negative x in. So I'm gonna plug a negative x in and see what I get out. So negative x squared plus 2. Negative x times a negative x, well, that's just gonna be an x squared, right? So this is x squared plus 2. Notice, guys, it matches. So if it matches 100%, you get an even function. If everybody's signs change, then that means it's an odd function. Because remember, it's odd that all the signs changed. That's how I remember it. Okay, let's try number 10. I'm going to distribute, I'm going to solve. That probably means I should probably distribute a 3. So 6g minus 3 is equal to 15. Add some 3. Divide by 6. I get g equals 3. This one, distribute the 3. Distribute the negative 2 in there as well. So 3x. Whoa. That one had a little bit of a... There we go. Whoops. Scoot it all the way to the bottom. There we go. Go back to my drawing area here. My eraser. There we go. Oh. Get rid of my pen. There we go. 3x minus 6 minus 2x minus 2. And that's equal to 5. Notice it's distributed in that negative 2. Let's combine some like terms. So 3x minus 2x, that's an x. Negative 6 minus 2 is a negative 8. That's equal to 5. I'm going to add 8 to both sides. Whoa, it's a little wonky here. And we get 13. There we go. Sorry about the mess, guys. Marsha's tablet's kind of weird today. Now let's solve the following equation for y. So that means I gotta get y alone. So this guy's gotta be alone. So I'm gonna add 3x first. Because remember, when you're solving, you're basically gonna do PEMDAS backwards. So you're going to add and subtract before you multiply and divide. Let's divide by 5 here, so I can get my y alone. So that'll be 3/5 x plus 12/5. There we go. Now this one says I gotta graph the equation. Probably want to be y equals form, right? So I'm gonna add 4x to both sides. So 2y equals 4x plus 10. Divide by 2. So this is my y-intercept. So I'm going to start at 5. 1, 2, 3, 4, 5. I'm going to go up 2 over 1 to do my slope. I'm going to go backwards 2 so I get a nice full line. And then connect my dots. To the best of my ability. Kind of went a little wonky there, but that's alright. Okay. Let's try the last 3 here. So I'm going to find the slope of the line passing through these points. Remember that formula is the rate of change formula. So change in y over change in x. So difference of the y's. So -4 minus 2. And 2 minus a -1 is what I'm going to do. Since that's a double negative, I get to change to positive. So -6 over 3, or my slope is -2. Now they want me to write the equation of a line with a slope of 2, and I'm going to pass through that point. Well, I can use my translated form, right? So remember, translated form looks like this. Ooh, that's an X. Okay, very similar to vertex form in parabolas, which is more what you've seen earlier. M is your slope, so I'm going to go y equals 2 parenthesis x. Now h is your x value. It's how far left or right did you go. Well, I went right 3, right? So I'm going to subtract 3, because that was always opposite of what you saw. And then I'm going to go down 1. I'm going to subtract 1. Last problem of this particular video. So I got to graph this inequality. So first thing I'm going to do is I'm going to get, so I've solved for y. I'm going to have -8y is less than or equal to -12x plus 24. Divide by -8. Oh, I divided by a negative, right? And it's an equality. So I got to make sure I flip that sign. So divide here. I'll get -12 that's 3 halves, right? X minus 3. So let's go ahead and graph that. So I'm going to go down to -3, go up 3 over 2 to follow my slope. There we go. There we go. And now, since this is an inequality, I do need to look at the sign. Since it's an equal to, I get to connect the dots with a solid line. Now, if it was just a greater than, then I would have had to have done a dashed line. And then what we're going to do is check with 0, 0 to see which side of this graph do I get to shade on. So 0 minus 0 is less than or equal to 24. So 0 is less than or equal to 24. That's a true statement, which means I get to color on the side of 0, 0. So that's the end of this video. Click to the next video so you can watch the second part of this semester review. And until then, see you later, Sabers.